Hello, my name is Trevor Wilson. I am a Sales and Support Engineer for ACCRETECH UK. As such, I look after sales and application support for all of ACCRETECH's products throughout the North region, which includes the UK, Ireland and Scandinavia. ACCRETECH as a corporate brand was introduced in 1989, but is an affiliate of the much larger Tokyo Sumitsu company, whose headquarters are in Japan and was established in 1949. Since then, they have manufactured and sold metrology and semiconductor products, and to this day we continue to introduce high accuracy, reliable and robust systems to the global market, respecting the core technology we've cultivated for decades. I'd like to talk to you today about surface finish, or more importantly, why we measure surface finish. There's many reasons for this, and I'll go through these now. Quality assurance. Surface finish is a critical factor in determining the quality of a product. It ensures that the surface of a manufactured part meets specified requirements, which is crucial in the aerospace, automotive and medical industries. Functionality. Depending on the application, certain surfaces need specific finishes. For example, a smooth surface might be necessary for sealing purposes, while a textured finish might be needed for a better adhesion. Fit and assembly. Surface finish affects how parts fit together. If a surface is too rough, it may not fit properly with another component, potentially leading to problems like leakage, misalignment or decreased performance. Corrosion resistance. A smooth surface finish can provide better protection against corrosion, as it reduces the likelihood of corrosive agents finding purchase on a rough surface. Aesthetics. For consumer products, aesthetics play a major role. A well-finished surface can enhance the appearance and feel of a product, making it more appealing to customers. Friction and wear. The roughness of a surface can significantly impact friction and wear characteristics. In applications like bearings or sliding components, a specific surface finish can be crucial for reducing wear and improving the lifespan of the part. Regularity compliance. In some industries, there are strict regulations governing the surface finish of components, especially those that come into contact with food, drugs or sensitive materials. Functionality of coatings. Surface finish can affect the adhesion and performance of coatings or treatments applied to a material. A proper surface finish can ensure that coatings adhere well and perform as expected. Instrumentation and measurement. Accurate measurement of surface finish is essential for quality control and assurance processes. It provides a quantitative metric to assess and compare surfaces. Cost and efficiency. Achieving the right surface finish can impact the cost of production. For example, excessively smooth finishes may require more time and resources, while finishes that are too rough might necessitate additional processing steps. Research and development. Engineers and researchers use surface finish measurement to study the effects of different treatments, coatings, or machining processes on materials. This helps in developing improved products and processes. Safety and compliance. In critical applications such as in the medical field, e.g. surgical implants, a precise surface finish is essential to ensure the safety and compatibility of the material with the human body. The first thing to think about when you're looking to measure your surface finish call out is, will I need a skidded or a skidless measuring unit? These measure in two distinct ways. One, we'll use a skid with the stylus needle poking out from that skid. The skid will sit on the job, it will trace along and measure. The other method, which is a skidless method, uses a stylus which is more like a record needle, and it is up to the operator to put this in the right position before starting the measurement. Generally, a skidded system will be used on a entry-level machine, which will then be used to measure big parts, lots of room, lots of access. A skidless system will then be used up to a high-end measuring machine. This will usually give you a variety of different probes, which will allow you to access more features, measure in much smaller areas, etc. Moving on from this, what is the difference between form, waviness and roughness? The best way of trying to explain this is to look at the picture of the sand dunes. If you look at the picture, the red line or the actual sand dunes would be what would be picked up as form. So certain things like radii, curves, small steps would all be classed as form. Moving on from that, the ripples on the sand dunes, or the slight undulating small bits of form, would be classed as the waviness. Moving on from that, the actual grains of sand would be the equivalent of looking at the roughness. So as you can imagine, the three distinct profiles could all be measured in the one hit. So as you would go around a radius, there could be some slight waviness as you go around that form, but then there will also be the surface finish across the tops of those waves as well. This would be the difference between the three different profiles. What is waviness? Waviness is a term used in engineering and manufacturing context to describe irregularities or deviations from the desired or expected form in a surface or profile. It refers to relatively low frequency deviations in a surface that are typically larger than surface roughness but smaller than form errors. Excessive waviness can affect visual appeal. For instance, in automotive paint finishes, waviness can be noticeable and detract from the overall appearance. In applications involving optical or imaging systems, waviness can cause distortions or aberrations in the images captured and displayed. Waviness can affect the contact and sliding properties of surfaces. It can influence friction, wear, and lubrication behaviour. Understanding and controlling waviness is essential for designing components with optimal tribological properties. One of the best ways to look at and govern the waviness would be to look at the WT. The waviness height, or WT, is the total height of the W profile. It is the sum of the largest profile peak height and the largest profile valley depth of the W profile within the evaluation length Ln. The W profile, or waviness profile, is the mean line generated from the P profile by the LC profile filter. The long wave profile components which belong to the form are excluded. To try and highlight why we would measure waviness, please see some examples of tool chatter and what is known as orange peel effect. Many thanks for spending the time to listen to this short webinar today. Please see my details on the screen. If you have any questions moving forward, please don't hesitate to get in touch. Thank you.